All right, are we good? All right. Good morning, everyone. I see there's a whole bunch of people in the back. There's actually a bunch of, I can see spare seats. So if you guys want places to sit, I can actually see quite a few seats. That's a pretty full room, but there's some seats around if you want to find a place to sit down, so come on in. My name is Eldon Christensen, and I'm with me. I've got Ned Pyle. Here's Ned. He's going to be doing the section on storage coming on. And so we are both program managers in the high availability and storage team in the Windows Server division. And so what we're going to talk to you about today is stretching clusters. And part of you might say, well, what's so new about that? Actually, we've supported stretching clusters since Windows 2000. So we've been doing this a long time at this point. And we have a very rich ecosystem of vendors which plug in and help enable stretching clusters. And that's been our story for the last decade or so of doing this. But what's so exciting for me about this presentation and what we're doing now is that up to this point, since Windows 2000, people have always come to me and said, hey, Eldon, I want to take clusters, and I want to make them not about just high availability, but also disaster recovery. And how do I do that? And then whenever we got to the storage piece, I'd always kind of go, blah, 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 blah. You're going to have to call somebody else. And then they'd always go like, well, can you give me guidance on what I should do? And I'd be like, well, you got to talk to them. And I really never had a good, complete end-to-end story. And so that is what's changing with Windows Server 2016, and that's what's so exciting, is that we're going to have built-in volume-level replication, and we're going to enable a stretch cluster story end-to-end with the Microsoft butt on the whole thing. So this is kind of the big exciting thing about what this presentation is about. And see if I can get the oh, hold on. Come on, PowerPoint, work with me here. Hold on, sorry. Here we go. Are we working? Yes, now we're working. All right. So again, we're going to talk about how to stretch clusters. One of my fundamental assumptions is I'm going to assume that you know about failover clusters today. So I apologize if you are kind of new to failover clusters, but what we're really going to, just in the sake of time, because it would take us maybe a 3-day class to cover up to this point, but we're going to talk about how to go from a normal cluster that you know today that you're using for high availability, and then how to use that and switch it to disaster recovery. So just kind of to set a base here just for a second. So you have your normal clusters that you're used to today, 2-node cluster running on a single site. But what happens if there's some sort of catastrophic fire or a tornado or something like that which takes out the data center? Obviously, you lose your entire solution. So what a stretch cluster is really about is, let's take those nodes. So here I've got, now I got a 4-node cluster, and I put 2 nodes in site 1 and 2 nodes in site 2, and they're stretched. So now in the event that I have a failure, services can automatically fail over from one physical site to another physical site. So this is what we mean by a stretch cluster, is you're stretching that cluster across geographic locations, across data centers, so that you can do not just failover from a server that's inches away to a server which is miles away. So let's talk about kind of RPO and RTO. So those are kind of the most important things to think about when you're thinking about your high availability strategy, or I should say your disaster recovery strategy. And so your RTO is the amount of time that you can be down in the event of a loss. So let's say you have a data center failure. Your RTO is how long can you be down? Can you be down seconds? Can you be down minutes? Can you be down days? Can you be down weeks? And then that really defines what kind of a solution do you need. If you can be down weeks, maybe just the normal tape backups you're doing are good enough, right? In the event that you lose a data center, you're going to get new servers, you're going to fire them up, you're going to reinstall the OS, and you're going to do restore from backup. So maybe that's good enough. And if you have an RTO of weeks. Some important things I want to talk about in kind of defining the disaster recovery story. So you'll see the terminology of automated versus automatic. Sound very similar, but they're actually very different. So automated failover is really manual failover. So that means in the event that I lose a site, somebody's going to have to, a human being is going to go have to hit the peripheral big red button to cause the failover from site 1 to site 2. So that's automated failover. Automatic failover is where you're having the system is health monitoring between the different sites, and in the event of a site, the system will automatically cause a failover from one site to another site and do that automatically. And so when you think about an RTO of automated, that means somebody's making a decision, you're probably having failover times in the amount of hours, right? Because you're going to have to notice that the data center's down. You're probably going to have a meeting to talk about it. Somebody's going to have to go fire up the tools, maybe get in a car, hit the red button, cause the failover. So you're kind of talking an RTO of maybe hours. And for a lot of people, that's acceptable. In fact, maybe 60, 70% of people I talk to, that's acceptable. And that's fine. It all depends on your business requirements. Automatic failover enables you to, if you're health monitoring, you get failover maybe in the matter of seconds. So those are kind of your RTOs. On the RPO perspective, that's the amount of data loss that you have in the sense of, hey, when I fail over, how much am I going to lose in the sense of data loss? And so synchronous, you think about synchronous replication, before an IO is committed back up to the application, you're committing it locally and you're committing it remotely before it's acknowledged back up. So in the event that you lose a site loss, you don't lose any data. With asynchronous, you're committing it local, and then later on you're writing it back to the DR site. Maybe it could be lagging by a few seconds, but the reality is you can lose a little bit of data. A lot of customers will say for things like maybe it's a file server directory, maybe it's for the marketing team to put some material on. That's okay if I lose a few seconds, but maybe you're a stock trader and that's not acceptable. So it all depends on your business and what you think about. And kind of one of the things about a stretch cluster is we can deliver the low RPO with the synchronous volume replication with storage replica, and we can deliver a low RTO by having automatic failover. So that's kind of one of the beauties of it. Now let me talk a little bit about, we have a couple different DR stories going on within Microsoft, and you're kind of like, well, which one do I choose? So let's talk about like in the virtualization perspective, like we have Hyper-V Replica, and then we have Azure Site Recovery as a orchestrator mechanism for using that. And it all depends on your business requirements. So you got to remember, Hyper-V Replica is going to be doing replication on every 30 seconds, 5 minutes, or 15 minutes. So your RPO in that perspective is going to be, you could have a potential data loss of up to 30 seconds. And from an RTO perspective, it's going to be automated failover, so it's going to be a little longer. So when you think about Replica and ASR and Azure Site Recovery, it's going to give you a little higher RPO, a little higher RTO, a stretch, but at a cost of, from a management, it's very simple. That's kind of the beauty of it, is it's very, 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 very simple. And so that may be spectacular for your tier 2 workloads. A stretch cluster, on the other hand, is going to give you lower RPO, lower RTO, but I'm going to be honest, it's a little more complex. And so there's a cost for that. So maybe you need to think about these things in kind of your DR strategies, and maybe your tier 1 versus your tier 2. So you're going to have maybe, and how you want to use them and where it makes sense to deploy. And just one more point, another trend, actually let me talk about that real quick. Another trend which is really evolving in the sense of disaster recovery is disaster avoidance. So in the sense that now the real strategy is that what's happening is when you see the hurricane coming, don't wait until the data center goes out. Proactively move everything from your primary to your second center. And that's actually one of the scenarios where Hyper-V Replica is incredible now, where you can proactively recognize there is an impending storm coming inbound, there's a hurricane coming in, and let's proactively move everything from one other one. We call it disaster avoidance. And so that's actually another way to think about your DR plans, is you can think about, okay, am I going to maybe I'll have a disaster avoidance plan, so when the big storm comes, and then what kind of RPOs and RTOs do I need to have in the event of a hard loss, of a fire, or of a tornado, something like that. All right, so let's set some terminology, because we always change the terminology. Actually, since I said we support this since Windows 2000, we've changed the terminology a lot. So you hear me refer to this as a stretch cluster. That's kind of that's the way we're referring to it. You might have in the past also heard me refer to this as a multi-site cluster. That's still okay. We actually kind of use that intermix sometimes. So if you call it a multi-site cluster, it's okay, but we're calling it a stretch cluster now. Now a metro cluster, a lot of times you hear metro cluster used, but a metro really kind of refers to the stretching of the distance of how far you're stretching it. So when you talk about metro DR, that usually means like across the river, so like New York to New Jersey. You're going a couple miles, not too far. When you talk about a geo, Geo means you're going a longer. Maybe you're going New York to LA, so you're going across geographies. We also, 10 years ago, used to call stretch clusters geoclusters, but actually another vendor ended up trademarking the geocluster terminology, so we don't use the geocluster terminology anymore. So you got like metro cluster, geocluster. Well, there's one thing you don't want to call it, is a geometro cluster, because then you're just going to look silly. So there's really three things to think about when you're doing a stretch cluster, different than a normal cluster. And it comes down to networking requirements, quorum requirements, and storage requirements. So let's go into drill into each three. Let's talk about networking first. So when you're stretching clusters, so there's two things to think about. So when you have nodes which reside in different data centers, you usually, as you're going greater physical distances, you're going to have more latency between the nodes. You need to think about that. The other thing is that you're going to have, usually in different subnets. So usually when you're in different data centers, you have different subnets. And then there's some considerations that come into it as far as updating IPs and DNS records and client caches and how that impacts failover time. So we'll talk about that. So the first one is around latency. So as you stretch these nodes over greater distances, you're usually going to have more latency between the nodes. The way which clustering comes out of the box, it's pretty aggressive. So we do this heartbeating once a second. So once a second, we're sending a heartbeat to the node, and he has to acknowledge. So we send and we acknowledge, and we send and acknowledge once a second. If a node doesn't respond to 5 heartbeats, we deem that there's something wrong with that node. And then we kick it out of the cluster, we go to recover, we say, oh, there's something wrong with it, he's gone dark, I don't know what's going on, need to recover. Kick him out, fail things over, get up and going. Now, the reality is on your WAN, you may likely hit little brownouts that'll last longer than 5 seconds. So you can actually end up with false positive failovers, where you have some spanning tree convergence going on, and there's a short little, maybe some, you're just having some high packet loss for a few seconds, and then the WAN kicks back in and things start working again. So you can have these little brownouts, and being at that threshold is actually a little too sensitive, I'll argue. So you're going to want to crank those up. So the first thing you want to do when doing a stretch cluster is crank up those thresholds for your latency. So now let's talk about crossing subnets and how this kind of works. So clusters, we do support nodes which are in one subnet, let's say 10.10, and another one which is in 20.20. But how do we fail over across them when we do that? So the way it works, we have a single network name resource. Let's call it foo. So there's a name of foo, and under there's going to be actually 2 IP address resources. There'll be one for 10.10 and one for 20.20. And the way it works is that when you fail over to a node, they're in a group. That group fails over. The IP address, which has a valid subnet network on that node, will come online. So if I have a 10.10 and a 20.20, when I fail over to the 10.10 node, the 10.10 will come online, the 20.20 will stay offline. And then what happens is that 10.10 address, the network name picks it up. It goes, oh, this is the valid IP for this network. This is what I'm going to register with DNS. When I fail over, that's going to inverse, right? So then now the 10.10 does not have a valid subnet on that 20.20 node. The 20 does. It will come online. Network name will pick it up, and then we'll go register with DNS. But this has some considerations. So let's talk about how this works. So here I've got a file share sitting on node 1 in a 10.10 address. A DNS record is created. It will go and create it with the DNS when the network name resource comes online. It will go and create it in the DNS in the server. Those DNS servers are going to have to replicate and push that record around. And if they're cross sites, it's going to take longer to push those across. Maybe it can take 10 minutes, let's say. Then the client is going to have to go and obtain that updated DNS record, the current DNS record. So what happens on failover? So now if I go and fail that file share over, I've now moved over to a 20.20. So now we have to, that share, so what's going to happen is that the IP address associated with that name is going to change. We are then going to go register with DNS and update the DNS record. We're going to say you used to point to 10.10, you now point to 20.20. It's now going to have to replicate. That's going to take, let's say, maybe 10 minutes, or however long your DNS replication is, if it's across sites. Now the client has to obtain an updated IP address. The client has a cache of 20 minutes. So the client isn't going to go hit the DNS server for an updated record for 20 minutes. So the short story of what I'm telling you here is that failing over across subnets is very cool, But it does have considerations, and it could mean that when you fail over across sites, your clients might not be able to connect for 20 minutes, maybe 30 minutes or something like that. And maybe if your data center just burned to the ground, maybe a 30-minute downtime while you fail over is okay, but maybe it's not. And where it's not is where most people are doing test failovers. They need to fail over. They're doing like a proactive power shutdown in one of the data centers. They want to shut down to keep downtime minimal, and they can't tolerate that 30 minutes. So in that kind of planned failover scenario. So let's talk about how to mitigate that. So the first thing is that if you are stretching Hyper-V clusters across it, you can actually use Hyper-V network virtualization to completely abstract the networking. So the virtual machines will be on a virtual network of 30.30, even though the physical adapters will be on a 10.10 or 20.20. So that way, when I go to do a failover from one location to another, the IP address associated with the virtual machine, the IP address that clients are connecting to never changes, and everything is completely abstracted with Hyper-V network virtualization. So if you're doing Hyper-V, this is the way to go. There are we have some dials and knobs that you can tune for this as well. So one of the things we have is called register all IP providers. So remember the logic I was talking about where we register whichever node comes online, we online the IP address and that gets registered in DNS? Well, we have another set of logic which says, hey, network name, I don't want you just to listen to whichever IP is online, register all of them. So what you're really doing is you're pushing the burden onto the application. And the application has to have logic to know, oh, I've returned multiple IP records with a single, multiple IP addresses returned with a single DNS record, and I know that some of them will work and some of them won't work, and I have to have that logic built in to handle that. SQL Server has that logic, so SQL Server can deal with it. So with SQL Server, you can register all the IPs, SQL will get them, and SQL has retry logic to try them all. And you can actually get fast failover with SQL, so you don't need to worry about all that DNS replication and synchronization. If you're doing this for clients, so let's say you're doing a file server, we also have this host record TTL. So I said it was 20 minutes by default. If you want, you can crank that down so that so the clients will hit the DNS server more often. Another thing you can do, so let's talk about mitigation. So let's say you're not doing Hyper-V, let's say you're not doing SQL, you're going to maybe be doing a file server or some homegrown in-house app. What are some other strategies? One thing you can do is you can do site local failover. So you really scale up the number of nodes. What I mean by that is don't do a 2-node cluster. Don't do 1 node here and 1 node here. Do like a 4-node or a 6-node cluster. And that way what happens is you have different SLAs depending on the failure type. So if you have a server failure, you fail over to a site local server. If you have a site outage, you fail over to another site, but you have longer. So maybe you have your SLA is seconds in the event of a server failure, and maybe it's 20, 30 minutes in the event of a site failover. And maybe that's okay. Maybe your business will say, you know what, for different failure types, I'll have different SLAs, and that'll be okay. Another thing you can do is you can go back to like the way we did this in 2003, the way we had to do this, clustering had to do this, which you can stretch VLANs across sites. Now, I can't promise you that your network admins aren't going to key your cars and slash your tires, but it is something you could dare to ask them. And that way, when you move that share over, IP never changes. So that's something you can do as well. Another thing you can do, another option on the table, is there are network abstraction devices which can map this all out for you. So like Cisco has devices, I've got a link to it. You can get this on the deck later. But they can abstract it as well. So they can kind of do what Hyper-V network virtualization does, but in a generic sense, where effectively on failover, the client's accessed IPs never change, even though under the covers, the IPs of the app are changing. Another thing I want to just mention is that we also have the ability, if you are stretching your clusters across insecure WANs, we do have the ability to turn all the intra-cluster communication to be encrypted. It's signed by default, so it's secure, but we can also change it to be encrypted so that that way if you are going across an insecure WAN and you're worried about someone sniffing the packets between the nodes, you can encrypt the packets between the nodes as well. So just kind of a recap of all the things I just threw at you really quick. So first off, make sure you crank up your heartbeat thresholds so you're not so sensitive so you don't get false failures on brownouts on the WAN. Understand what you want to do around your network name resource. Are you doing Hyper-V? Are you doing SQL? Are you going to stretch those VLANs or not, and how are you going to do it? And if you want to, you can encrypt that intra-cluster communication. All right, so let's talk about quorum considerations. So when we think about sites, you have, the biggest thing in consideration of quorum is that you are going to be losing multiple nodes at a time. So the first part is that when you have two sites, you got site A, site B, and one of those sites goes down, or if there's a split between, that's actually the more interesting scenario. Well, WAN connections lost between the two data centers, we need to prevent what we call as a split brain. So a split brain is where maybe these nodes are running and these nodes are running, and they both think they're running the cluster, they're both trying to host the resources and the applications, and they're both trying to make forward progress, and they're both just running without talking to each other. That's one of the guarantees we have to ensure we don't do with clustering. So that's one of our fundamentals that we have to deliver. So we need some mechanism to decide when there's a split and these guys can't talk to each other anymore, we need to decide who stays up and who shuts down. We don't want everybody shut down because we got to make sure that cluster stays running, but we got to shut some of those nodes down. And so we use votes and a majority of votes to achieve quorum to decide who should stay up and drop down. Votes can be assigned to different things. Votes can be assigned to a node, and each node can have one vote. Nodes can also be assigned to a witness. You can have one witness, and we have a couple different flavors of witnesses. Disk, file share, and I'll be talking about a new one called Cloud Witness in a second. So you can have one for the witness and one for each node, and you need a majority of those. And one of the big considerations is that with a stretch cluster is you're losing many votes simultaneously. So imagine you have an 8-node cluster, 4 and 4. Simultaneously, when that site goes down or that connection's lost, you're losing 4 votes all at the same time. So clustering deals really well with losing 1 or 2 votes at a time. But when you start talking about losing a lot of nodes at the same time, then you have to think about that in your deployment planning and strategy. All right. So let's take an example. Here's kind of utopia of what you want your scenario to be. I got site 1, I got site 2. I have an even number of nodes on each site. I got 2 on site 1, 2 on site 2. If I count my number of votes, 1, 2, 3, I got 4 votes for the nodes, and then I have a witness. And that witness is my 5th vote. So I have 5 votes. I need a majority of votes. That's 3 out of 5. So I need 3 out of 5 votes for the cluster to stay up. So take this scenario. If site 2 goes down or becomes partitioned on the network, what will happen is that site 1 has 1 vote, 2 votes. It has the witness, still can communicate with the witness. That's 3 votes. So that site goes, hey, I have 3 out of 5 votes. I'm good. Now, if for some reason that site was network partitioned, it's going to go, okay, I have myself 1 vote. I have this other node. That's 2 votes I can communicate with. That's 2 out of 5. That's not majority. I shut myself down. So then the site's going to automatically shut itself down. So what you've achieved here at the highest level is your cluster is resilient to any one site failure. So if I let me take this back for just a second. So if I lose site 1, I still got site 2 has 2 votes in the witness. If I were to lose site 2, like I just showed you, 1, 2, 3, and if I lose the witness, I still got 1, 2, 3, 4 with sites 1 and 2. So your cluster is resilient to any one site failure. So let's talk about the cloud witness really quick. So when I go to this picture here, and so what's the story today with Windows Server 2012 R2? What I would say to you today is I would say, hey, go put a file share witness in a 3rd location. And the immediate response I get from like 98% of the people is they're like, Eldon, you're insane. I do not have a 3rd data center. I have 2 data centers. You cannot tell me to go put a file share in a 3rd data center. So we've been working to improve this. So we have something called a cloud witness, where you can leverage the power of Azure to be your witness, to be your decision maker on who should stay up and who should drop out of cluster membership. And so basically it works just like a file share witness. We're storing just a blob with a sequence number up on using Azure Blob Storage, going over HTTP, and I'll show it to you. Let me show you what it looks like. Hold on. All right, so I've got a cluster here. And so if I just go, let me actually show you something else first. So the first thing I wanted to show is I've logged into so I've created an Azure account, and I've logged into my Azure account. And I've created some blob storage here. And so here you'll see it, and I just named it Cluster Cloud Witness. So I can go in, let me actually go back one. So I can go manage keys, and it will give me the keys associated with this blob storage. So I'm just going to copy these keys. I'm going to save these for later in a second. And I can go in here, and I can go into my witness. Oh, sorry. Click here. And then here's my data. And then here you can see my Paxos tag, which is going to be stored, which is just a sequence number associated with updates in the database. And this just works just like a file share witness. But let me show you how to configure this. So I've gone in, I've gotten my key. Now I can go into more actions, configure cluster quorum settings. I say, I'm going to select, let me show you what I'm running first, actually. So right now I'm running a file share witness. So if you look right here, I'm running a file share witness. So I go into more actions, configure quorum settings. I'm going to select a witness that I want to use. And so the new one you're going to see here is it's the same UI and wizards you're used to, but you're now going to see I can configure a cloud witness. So I go to my cloud witness, and then it's going to ask me for my name. And the name was what you just saw me have here in the storage here a second, which was cluster cloud witness. And let me go back. You can see that. Here you go, cluster cloud witness. So I put in cluster cloud witness, I'm going to put in my key. So I put in cluster. I put in my key. And you can actually use different endpoints. So there's different endpoints coming up as far as like in China, government, different flavors of Azure. So this works with different flavors of Azure, and you can just put in your endpoint if you're not using the default. And so I'm running a min shell, so usually there's a nice, actually this is something we're improving in current builds, actually, is we're, so in that min shell there's no, so what that page was is that there's an HTML report which gets displayed, and let me go back, and that's why it says cannot be displayed. So now if I go and look, you will see I have a cloud witness configured here. So I'm just using the power of Azure, and now I can actually go back into here. And here you will see, where are we, 5.7? So here it is right here. So now it's gone, and I can look, and so it's gone, and it's using this, and here it's going to put the Paxos tag on it. So that's using a cloud witness, and that's all it is. It's fully integrated and very simple. All right, and with that, let me flip back, see if I can get PowerPoint going again this time. So let's talk a little bit about picking a witness. Which one should I go with? Cloud witness, file share witness, cloud witness, file share witness. Which way should I go? They both use the same arbitration logic. And so they both don't, and they don't actually keep a copy of the cluster database and then cloud witness is actually important, right? So there's no information about your cluster. There's no private information. It is nothing more than a sequence number which is being stored in Azure. So there's no worry about any sort of state which you are concerned about from a privacy perspective being stored in Azure or being transmitted over the wire. It's just simply a sequence number. And it's just, and cloud is writing to blob storage, and a file share witness is just writing to a text file on an SMB share. It's using REST APIs over HTTPS versus using SMB protocol. You do have to have a Microsoft storage account versus you have to, for a file share witness, have a file server to configure it. So the first question, which everybody asked me, so I'm just going to preemptively answer the first question I know you're going to ask me, is how much does it cost? You expect me to use Azure, you're going to ask me to set up an Azure account. So we were very cognitive of this when we set up the Cloud Witness and when we designed the Cloud Witness. And we recognized the Cloud Witness, for Azure, you have to pay for storage and you have to pay for egress in and out, right? So you're paying for access in and out. So we tried to be very minimalistic. Now, I can't make any promises, but Azure pricing changes. But in our testing so far, the good news is that Azure does it rounds to the nearest penny. And we haven't been able to get, in our testing, this to get the round to the nearest penny. So I'm not going to say it's totally free, but it's going to be very, very low cost. So let me give that to you. So let's talk about if you're using 2012 R2 today and you don't have a third site. Or maybe you're deploying in 2016 and you don't have a third site. You don't want to open this up, the nodes to be able to have access to Azure to be able to use a Cloud Witness. So technically, clustering will survive a 50% split. This is actually something new in 2012 R2, actually in forward that we have new logic. We will support that if the nodes have a 50% split where half the nodes are lost, we will elect one site to win and to survive. So if you're deploying with just 2 sites, you can do 2 nodes in one site, 2 nodes in another one, and when they split, we are going to randomly elect one to win. Now you can control which one wins. So we have a little property that you can go and say, hey, this is my primary site, I want it to win. You can also configure manual failover. So many people in this room may be like, I don't never want automatic failover. I only want manual failover. I want to go into, when something really catastrophic happens, we're going to get together, we're going to have a meeting, we're going to make some educated decisions, and then we will execute upon those plans. I don't want automatic failover. That's okay, we can do that too. So you can actually go and toggle, so I talked about each node has a vote. You can actually go and toggle manually the votes on the nodes. So if you never want the DR site to win ever, and you only ever want to go to the DR site when you manually say you want to do it, then you can actually go and drop the votes off those nodes and set them to 0, and then you can do a manual failover to the sites. Another thing we have is that you can configure preferred owners. So let's say you have an app and you want that app usually to run on the primary site. You can go and define we have a sort ordered list called preferred owners, where you can say, and it says, I want you to usually live on this node, and if not this node, then that node, then if not that node, then this node. And you want those, and you basically define them to your primary site. So this can help give you some site affinity in where you want things to live. Okay, so just a quick recap here. Always configure witness with 2012 R2 and forward, stretch cluster or not. That's the general recommendations. Cloud witness is the best to use because most people tell me they don't have a third data center. When you don't have access to a third data center, you can use a file share witness. For automatic failover, try to keep the number of nodes equal because you want any node to be able to survive in the loss of another one. And if you want to do manual failover only, you can drop the node vote weights off the DR site. And you can even do a lesser number of nodes. So let's say you had 4 nodes here. You do 2 nodes here, drop the node vote weight, who cares, because that site's never going to win. It's only when you go and hit the big red button and force that site to start when it doesn't have quorum that it will work. All right, and with that, I'm going to hand it over to Ned.
Thanks. You guys hear me okay? Thank you, Johnny Cash, maybe Roy Orbison. My name's Ned Pyle. Like Eldon said, I'm a program manager in Windows Server. He works mainly on clustering. I work mainly on storage. So I'm going to spend a little bit of time today delving fairly deeply into this new feature called Storage Replica. This is as much as I can fit into about 30 minutes. If you come and see me at 5 o'clock today, I will do a full deep dive on Storage Replica. So Storage Replica is a brand new feature in Windows Server 2016. It is here to help you with your disasters. So what kind of disasters are we talking about? We're talking about this kind of disaster? That's the Hollywood disaster, right? That's our mascot. That's Jake. You'll see a lot of Jake at 5 o'clock. If you come and ask me some questions after we're done, I'll give you a nice Jake sticker for your laptop. See, I have swag. I have pull with marketing because I got a brand new feature. Okay. What about a real disaster? Okay. Superstorm Sandy in Manhattan in 2012. On the left is the Verizon main data center downtown, their main switching station. That's the lobby. So you can see it's about 3 feet in the lobby. Where do you think all the cables and servers and stuff are? They're in the basement. So they're all gone now at that point. I hope nobody's here from Verizon. I'm sorry, guys. On the other side is the storm. Look how big that thing is. That's the Verizon data center I'm pointing to. That's us. That thing is huge. If you had had your servers in a cluster in that data center, they're all underwater, and no matter how resilient they were in that rack, it's not good enough. Storage Replica gives you block level volume replication. synchronous or asynchronous, using SMB 3.1.1. We use this protocol. We introduced SMB3 in Windows Server 2012, and we've been building on it ever since. And every new piece of technology we build that uses network transport, we use SMB3 because it gives us multi-channel, it gives us encryption, it gives us RDMA support. I'll show you some cool RDMA stuff at 5 o'clock. Storage Replica is flexible. It works on any Windows data volume, any fixed disk storage. I mean, I'm talking about it for cluster right now, but it doesn't even require clusters. You can do server to server, just standalone volumes in 2 nodes, not even clustered. You can do cluster to cluster. You can do a stretch cluster, which I'm going to focus on today. Any storage fabric, fiber channel SAN, JBOD. If you've seen Klaus Jorgensen's session, will be at 3 o'clock today or something like that. He shows off storage spaces direct. Local DAS in a cluster. And you manage it, if you've been using Windows clusters for years, you're familiar with Failover Cluster Manager, you continue to use Failover Cluster Manager to manage your replication. So you get a nice UI, it's integrated into the workflow. If you've used FCM, you already know what you're doing, and I'll even demonstrate a little bit of it today. You can also use Windows PowerShell. Everybody loves Windows PowerShell. Yeah, okay. Most people could care less about Windows PowerShell, I know. You can use WMI, and what you finally get out of this, as Eldon alluded to at the beginning, is if you want a single throat to choke, and you want it to be us at Microsoft, you can finally do everything with one vendor. You don't need to go and get a third-party piece to add it on here to make your stretch cluster, to make your replication work. So let's do a quick demo. Oh, lovely. Let's go over to this node. Yeah, he's fine. So this is my cluster, the one that Eldon was monkeying about with here a second ago. It's 2 nodes. One server's in Redmond, one server's in Bellevue. Bellevue is the city just to the south of Redmond in Washington. They're really in the same rack, and you know, it's not actually in 2 sites. You think they'd give me money for the demo to put things in 2 cities. Okay. Just imagine. I got some disks. You might have noticed this column over here. That's new. There's a source and a destination. And I'm running a VM on here. Okay? If you keep your eye on this little floaty guy over here, you'll see these on all the screens. Because I flip them back and forth between different nodes, it gets a little tricky to see which one I'm on. Just keep your eye on the floaty guy. So over here, I just have a VM running. Okay? And this VM is going to send some data to my protected VM that's in the cluster. This one's just sitting off somewhere. It's my client. It's really my DC, but I'm just going to pretend to be my client. Okay? Over here, on O2, that server, we have so many failover cluster managers running here, it's ridiculous. Is my VM. This is the guy I'm protecting. And I'm going to move him, live migrate him real fast, over to the other node. Just because I want everything on 2 for a second here as part of the demo. Okay? Whoop, there we go. Coming back. I'm alive. And my frozen fingers might be a little bit hard to do passwords here, so bear with me. It's so hot in McCormick Place. Okay. At some point, I fried him. So this guy is actually a SQL server and a file server, and he's basically my guy I really want to protect between sites. Okay? So he's got a file share on him over here on the D drive. There's nothing in there right now. He's running SQL. If I pop some data into his SQL just to show that this is the real thing, you'll know that I was really on this box. Here's my incredibly complicated database. And here's a query. And if I come down here and steal my my little simple query. All I'm going to do is just pump some data into the database. Because what I want to prove to you, and I wrote the world's worst query so that he would take a long time to run. I really want him to take a long time here. Okay. Don't use that as an example of any SQL ever. You'll get laughed at by your DBA. Okay. Over here, I'm going to start copying some data into that server. Just copying some stuff. Just random pictures I've taken over the years. Okay? So I'm copying files into that VM. I'm doing SQL on that VM. And if I hide this away, just to prove that this is the same VM when we're all done. Here's Kerry and Bill Gates. He's from the Department of Stiffs. Head stiff in charge. Here's me. You know where this is going. Yeah, me and Bill. Look how happy Bill is. Oh, you've done such a great job with Storage Replica, Ned. The company's in good hands. Pals forever. Okay. So all this stuff's running. So let's go over to my disaster. This is my disaster. Here comes Jake. He picks up a bus, gives it a throw, hits that node over in Redmond. Let's see if the KVM gods will play nice to me right now. Looking good. So here's that machine. Here's the power button. Should I do it? I think I should do it. Yes. Goodbye. So that machine's gone now, and because he's a very old machine, he will not be back for a long time. Maybe about 15 minutes or so, thinking about the BIOS, and oh yeah, that connection's dead. Goodbye, machine. So what's been happening in the meantime? Well, looky here. The source of my data is now on O3. And the time it took me to go hit the power button and come back, I have failed over automatically. I was doing synchronous replication the whole time. All my data is already there. It has to be there. Every time I put my face on John Kerry's face, that I/O of my face has to get on the other server. I have a synchronous face. Node 2 is down. He'll be down for a million years, trust me. And if I come back over to my place where I'm copying data, I'm going to go ahead and try and cancel that. Xcopy really never wants to play ball and turn himself back on. The funny thing about Xcopy is when he says the last file he copied, that's the file he was really working on. It's the one before that. And we'll take a look at that in a second. Yes, I'm done. So I come over here back onto my new survived server, the only one that's left. My VM's back up. My little frozen nubbin fingers here will hopefully log in. Okay, good. I mean, he certainly got powered off. He was running on that server, but let's see. Do I have files? Were they still copying? Yes. There's all my files. Does anybody remember what the last file was that I copied? It was that one, right? File's okay. There's the Parthenon. This is one of my last little vacations. Let's see about the database. Does the database look okay? Well, it connects, so it must be running. It's loaded. There's my database. There's my table. Does it have data in it? Let's see if it's got data. I think it's got data. All this stuff was running when I killed the node. It's over at an entirely other site, perfectly fine. I'm still pals with Bill Gates. That's Storage Replica. Okay. One appeasement of the demo gods down, one to go. Stretch clusters are, in our implementation, synchronous only. You could do asynchronous. There's no technical reason not to. We just think it's sort of silly if you want to have a stretch cluster that protects data. The idea of a cluster is you never lose anything, right? So To have it sometimes be able to lose things seems wrong to me. It uses asymmetric storage. You saw that each side had their own set of shared storage. We can use CSV, or you can use PDR. And I always say PDR like everybody's going to know what I mean by that. And physical disk resource, the old thing before CSV, which I guess never got a name because there was only one thing, and then CSV came along, we needed to have some kind of name. You manage with Failover Cluster Manager or Windows PowerShell. Increases your DR capabilities, and what we really want you to use it for is Hyper-V and file servers. Not scale-out file server. In this particular preview that you have access to right now, all the stuff I'm using is on that preview. Everything I do, you can do. I don't cheat and fast forward into our dev branches to show you stuff. Scale-out file server will run stretch, but it's active across the sites. And we don't have the site awareness baked in yet for your client to be able to know which node has the storage, which node is the source. And so you can use scale-out, but it might be slow sometimes in random ways, and nobody hates random slowness like everybody in this room, right? How does this work? You have a source server and a destination server. You have some application, MS Paint, Hyper-V, SQL. You send an I.O. to the source server. That I.O. is written into a log. We keep a transactional log. We trap every single write I.O. that happens. We also send that I.O. at the same time to another server, and it writes to its log. This looks like it's happening sort of, in different steps. It's really not. It's in parallel. But until that one comes back, that I.O. is not done. So that middle layer and that storage on the destination, you want to be as fast as possible. Only then do we return the I.O. back up to the application. And then we write to the actual data volume, which means that SR is kind of like another cache. It's a spot where all your I.O.s really go, and they're always hardened to that log, hardened to that log's disk, and then they are eventually flushed out and hardened to the data disk. Which means that if you put your logs on a fast bit of media, and you keep your data spinning Rust or whatever you want, we act like a cache. We even aggregate I.O.s, something that Windows does not do. We try to take as much of your I.O. and shove it into a 2 megabyte message packet within a single tick to send that across. And if it doesn't work out, we send it along anyway. We can be as inefficient as your app wants to be. So again, you send your I.O., it splits off and writes to 2 separate logs before returning to the app. That's simple. This is not like conceptually a new thing. People have been doing this kind of replication for 20 years. And then we harden that data onto the data disk. Everything is always written through. There is no way for your data to ever not be on a disk in order for it to complete. We have 2 goals with this product. Be as reliable and safe as possible, and then be as fast as possible. We want to take away as much overhead as we possibly can. If you come to that 5 o'clock, I will show you some very interesting performance demo. So the next question. What are the requirements? There's Jake. This is something, when you see this little tag up here, is something that I haven't told anybody until I've told you. So you get to be the first to hear some stuff. That's the whole point of coming to these big giant conferences, right? That and the t-shirts and people in the booths pretending to like you. Yeah, the people at work don't even pretend, so this is nice, right? Okay. We ship this in Data Center. It'll also be in the MAS SKU, also in the Microsoft Azure Stack SKU that they announced a couple days ago. But this is not an add-on. This is not costing you anything more than server. So if you're buying server, it's free. Who here is actually using replication right now with a storage array provider or the vendor? Is it free? No. Could you pay for a kid to go to college on the annual? Like an Ivy League college? Yes. We need Active Directory, but not the way that you are worried about. I don't need you to update your schema. I don't need any objects in AD. No one needs to be a domain admin. I just need Kerberos. All I need is Kerberos because we're using SMB. I need a gigabit network between your servers. That is arguable for a requirement, and it doesn't really matter anyway because to get a logo for Windows Server requires you to have a gigabit network interface. I'm talking about the actual network between the servers. If you've got very little data replicating, you can get away with less over your WAN. But 125 megabytes per second is, give or take with the various overheads of SMB, TCP, et cetera, a gigabit. That's not very much data, not very much pipe for what already is a pretty, pretty likely amount of data coming through a busy SQL server, Hyper-V server. Your disks, you cannot be initialized as MBR, the old-fashioned MBR. They need to be set to GPT. That's a dynamic thing. You just flip it on. You need available storage. Whatever the cluster says is available storage, I'm OK with it. You need the same disk geometry. When I say that, people kind of their eyes cross. What I mean is, if I've got 512E disks and 4K disks, their blocks will never be the same size. Remember, I'm doing block replication, so they have to be at least, I don't care if they're the same make, the same model, the same manufacturer, I could care less. As long as the sectors, the blocks, are the same size, I'm good. And then free space for logs on a volume that you set aside for replication. And then obviously we're going over the networks. You need SMB, and you need WSMan. WSMan is the WMI, PowerShell, et cetera, management. I would assume that most of these things are probably both open already. Now some recommendations. Network latency. The next question everybody asks is how far apart can they be? How far apart? Well, if you're talking to Albert Einstein, it can be 1,500 kilometers. As long as you put your servers in outer space, to international space stations, we want 5 milliseconds or less of round-trip latency, and that works out to, at the speed of light, 1,500 kilometers. The reality is it's probably more like 30, 40, 50 kilometers, depending on who your fiber provider is, your telco, whatever you're doing on your network. If you've put 75 firewalls and switches between stuff, that's what matters, the latency. The bandwidth is up to you. You need to figure out how much bandwidth you're going to need based on how many write IOs you're doing. And if you come to the 5, I'll show you a technique. We actually give you a tool to figure this out. But all you really want to do is understand with a perf counter how much IO is being written on my servers that I plan to replicate. And then do that math in your head of how much bandwidth you need. And then for the log volume, you want something fast. SSD, NVMe, NVRAM, NVDIMM, something good. If you go out to the floor, right now the data on guys are out there. They'll sell you these cluster-in-a-box machines with like a million SSDs in them. They're amazing. I just took delivery of a couple of them, and they're so unbelievably fast. The price of flash, at least for the few volume, for the few disks you would need for your volume, has gotten so low that they're just kind of being included now. The bigger your log, the longer you can have your disaster. It's not about speed. The bigger log doesn't buy you anything. You can keep a very small log if you want, if you're being cheap on the logs. All that does is say, how long can the other server be turned off, the destination be turned off, before my log will wrap, and when he comes back on, I'll have to replay my entire volume. That's what the log is. If he comes back on and my log hasn't wrapped, I can just send him the difference of my log. That's really, really fast. If he comes back on and he's been off for days and my log already wrapped 2 days ago, I will have to give him everything again because I can't trust him anymore. I don't know what he knows. He doesn't know what I know. We make this a little bit better because we have a process built in called seeding that says, well, let's try and check the blocks and make sure that, well, I already sent you these, I already have these. Let me just send you this difference after I scan my own disk. That should save a little bit of time. But you really want your logs as big as you can in order to protect as long as you can. And we give you a tool, I'll show you at 5 o'clock, that'll tell you exactly how long your logs will need to be. And we're even talking now about doing some heuristic stuff in the product, which may or may not come out in RTM that would take care of even that thinking for you. They're recommendations, but they're like Microsoft recommendations. We're too scared to say the requirements, but they really are. Okay. You've seen this UI. It's pretty familiar. There's some new pieces here. There's a replication tab. There's a replication role that shows source and destination. And there's an entire section that shows you who's doing what with who, in what state they are in. And there's a very simple wizard you can walk through to set up replication. So let's walk through the wizard with some simple replication. I'm going to have to do a little moving and shaking here for a second. Hang on. Okay. So here, you can see this all right. I'm on another server. This is all running on this laptop. If you want to virtualize all this, that's why we made sure we put it into regular server. You want to virtualize this product and run stretched VMs, knock yourself out, totally supported. Now don't do it on this laptop because this laptop is terrible. So I have here all this storage. It's all living on node 4 right now. I have 4 nodes, in no particular order it appears, and they're all in a single cluster. So the nice thing about this UI, we spent a bunch of time putting it in front of customers in a lab, in a usability lab, you know, the thing where you have like a one-way glass mirror, and we watched them go and try and set stuff up. And the first time we did it, like last year, we went and we're like, man, we got this clue admin down. I can't wait. 10 out of 10 failed. No one can set it up. Holy crap. Okay, work. A few months ago, we did it again. 10 out of 10 succeeded. That's with no instructions. Because we had made it so that the UI would tell you when you were doing things wrong. It wouldn't let you go any further than you needed to get stuff done. So for example, if I pick this volume right here to start replicating, I choose replication, it says, no, you can't replicate available storage, dummy. You got to have some kind of something on there. All right. Let me make this into CSV. Whoops. So now it's a CSV. It could be a PDR, remember. Now if I do replication, yes. If I chose this 1 gig disk over here, and I said, oh, I could totally make him do this, right? Okay. He's a CSV too. No. You didn't do the GPT. I told you to do GPT. Make sure it's GPT. Okay. Take it easy, failover cluster manager. You jerk. All right, get that out of there. Yes, I'm very sure. So I'm going to enable replication. It's a nice wizard. That wizard also tells you about prerequisites, recommendations. If you read it, you're not going to read it. When's the last time you read a wizard page? I worked in support for 8 years at Microsoft. No one has ever read a wizard, ever, in the history of Microsoft. Okay. It lets me pick any volumes that are the same size. Remember that geometry, right? I only have 1 4 gig disk here. That makes it kind of simple. So that's the destination. And now it wants me to pick a log. I'm going to have some different options because logs are just about free space. We put the log on there. It's going to be 8 gig by default. You can go back later and change the size using a property page, which we haven't implemented here yet, or using PowerShell. I'll pick this one just because I like to use less space for my log. That's my source. You can see in the background here, it's moving these resources around so I can understand them because this is asymmetric storage. I'm going to pick the similar size one just to be anal retentive, but I don't have to. I could choose to overwrite the data on that volume, or if I have seeded it from a backup, from a split mirror that I copied disks and shipped them over through FedEx and plugged them into that server. If I've already got data on it, I can say, try and use as much of the data that's already there. The similar blocks. In this case, there's nothing there. I configure replication on this really slow laptop. This really slow laptop. There we go. Come on, Bubba. He brings everything online, and the replication is configured, and I'm doing initial sync at this point. What does that mean? That just set up replication. Under the covers now, I'm making that other volume look identical to my volume. And I'm going to do a little cheating here. Let's see, what's my destination? Destination is 06. So I wasn't even planning to do this in the demo because I got a little bit of extra time. I'm going to do it. I'm on 06. Am I the luckiest man alive? Yes, I am. Wow. This is like the best demo ever. Okay. If I fire up Event Viewer, remember I'm using Min Shell, but Min Shell still lets me run most graphical applications, just not Windows Explorer and Internet Explorer. So that kind of nice, bit of both worlds. And it doesn't mean I can run them very fast, obviously, but I can run them. Here he comes. He's also thinking very hard about replication right now, this poor little VM with its 1 gig of RAM. If I drill down here into the Microsoft area, Windows, Storage Replica, big, move. I can see every last thing it's doing. Here I configured replication. I established a partnership. I started preparing. This is the progress. See the bytes changing? Right there, copied bytes, remaining bytes. It's done. No warnings, no errors that you're supposed to ignore. I spent a lot of time on these events to make sure that if you got an error like down there, it's something you should actually go look at. This event right here says, hey, somebody set up replication, and it took that long exactly for that many bytes exactly. So if you want to monitor this stuff using System Center, using our management pack, if you want to roll your own, you want to see the complete history of this and when stuff was happening, it's all very tightly done in the event system. And if I come back to this, and I switch over to the replication tab, and I pick, let's say, the source, and I wait for this thing to refresh on my terrible laptop. You get to see the state everybody's in all the time at a glance. Who's replicating, who's recovering, who's in a failure state. Maybe I should be doing something right now. It's all right there in that dashboard. Very easy. Okay. If I want to move replication, sure. I want my source to be in the same site. Okay. That's it. Now it's in the same site. It's not a very exciting demo, sorry. It's really, really fast. We don't want to interrupt any workloads. If I want to switch sites, I just pick a node in the other site. By moving the disks around, whoever's the source goes over here. You want him to be the source? Okay, he's the source. It's that simple. That is managing a stretch cluster with Failover Cluster Manager. We have a session at 5 o'clock. I've said this a few times. If you want to learn about all the intricacies of Storage Replica, how it works, the do's and don'ts, see some more animated gorillas, that's the one to go to. I told you, animated gorillas. I'm killer with PowerPoint, man. I mean, I can put a little tiny top hat on any gorilla you tell me to. Now, we have about 10 minutes left for questions, because Eldon talked about 4,000 miles an hour. So if you want to ask questions, please come to the mics and shout them out. If you come by after your question and you want maybe a little sticker, I'm happy to give you one.
Can you turn the mics on? Okay. We'll repeat the question so everybody can hear it.
Will you there we go. Will you support replication on MBR disks at some point? I assume you can't replicate the C drive if it has to be a GPT disk.
Yeah, so we don't replicate, we replicate data volumes, not the OS, and we block MBR intentionally right now because it has crazy partition formats that can't be predicted because it dates back to NT. And GPT is awesomely predictable and works perfectly, so we use just GPT out of our own self-preservation.
So on the file server scenario, if you've got an implementation with DFS namespaces and DFSR replication group, in what situations would you switch to using a stretch cluster for a file server?
Rather than using DFSR?
Right.
If you want your data to arrive that year. I own DFSR, so I get to say mean things about DFSR. The difference is the performance. DFSR is not broken, it was designed to minimally use your network and to be fanned out to thousands of nodes. SR is almost its evil twin. It's designed to be super fast, eat your network for breakfast, and keep your data totally in sync all the time. So it comes down to which is more important to you. A big multi-master fan out that gets there when it gets there, or a small, narrow set of stuff that you can guarantee the changes are always getting there instantly. That's the difference. Mm-hmm. Yes?
You mentioned the logs. Is a log expandable or
yes.
go across node or disk?
Yes, so the log can be put on across, the log container lives on a virtual disk. You can have multiple logs. You can put multiple logs on a volume, or you can have logs spread across, well, you don't really spread them across volumes, but you could have lots of volumes doing logs for different things. They are fixed size, so when you say you want it to be a size, it doesn't grow or shrink. And if you want to grow or shrink it, you can. So you don't have to live with the logs no matter what.
I was just concerned that there's going to fill up and do your...
Yeah, it can't fill up. It cannot get any bigger than you say it will be. So the only way it could fill up is if something else fills up the disk, which doesn't really help you that much if somebody else is out of control, but at least it wasn't my fault.
You said SOFS isn't supported for this. Is that just for the synchronous side of things? I know you said there's synchronous and asynchronous.
Yes, so when we do scale-out file server, if you do cluster to cluster, and you want to do sync or async, that will work perfectly, and in fact, that's one of our desired scenarios. Okay. And that includes doing not just scale-out file server with JBOD or SAN, but also with Storage Spaces Direct, the new feature in 2016.
And then you'll be able to use Azure Site Recovery to manage it. So you could have a cluster here and two totally separate clusters, and use Azure Site Recovery to manage failover
so all that orchestration is handled with a giant, nice UI in the Azure portal where you can press a button and say, look, I'm about to have my disaster. Can you get this stuff out of here?
Is Azure Site Recovery required?
Say again?
Is Azure Site Recovery required?
No. If you want to use PowerShell, knock yourself out.
Perfect. Thank you.
Sure.
Question for Eldon. In your examples of setting up multi-subnet networking, et cetera, with the stretch cluster, used a file server role. Does those same recommendations apply to an SOFS role?
So with a scale-out file server, actually doesn't work very well today for doing a multi-site cluster. Because the problem is that with a scale-out file server, opposed to what I was talking about where network name registers individual IPs, the way a scale-out file server works is we don't use IP address resources. We take the local nodes of each individual server and we register with DNS. So, and then DNS run robin kicks in. So when a client comes in to access a scale-out file server, DNS run robin will just toss them across the nodes. And what you could end up with is a client here going to a node over there, then the next client over here going over to there. So we really don't recommend doing scale-out file servers stretched today, but we're thinking about this and how we can make it better. So.
Thanks.
Question for Ned. Can you write at both disks simultaneously?
No. And this is a rule of replication in general for block replication. You have to write at an authoritative source and send to a non-authoritative destination because while you have the ability to mount a read-write, sort of a snapshot copy that you can work on and then discard when you're done, if you actually try to write the real data from the file system on the top and the blocks underneath, your file system will just corrupt. So we don't let you do it.
Are there any plans for parallel file systems, something like GPFS or anything like that?
Oh, we always have plans for some stuff. But
Anything we can talk about?
no.
Okay. Thank you.
Yes.
Two questions. Do you guys support data dedupe on the cluster share volume?
Yeah.
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 When it
SR doesn't even know or care that you've got dedupe going on. It's way too high up.
Gotcha. And one thing I may have missed, what happens when if you have a site failure on one side and data log volume fills up over the 8 meg, or 8 gig rather, does it actually just panic, or does it just start committing and you have to reseed on the other side?
So if you lose the secondary, so when you're writing to the source and the destination goes offline, we don't stop letting your IOs work. You continue to write. If that server ever comes back up, the secondary, or if that other half of the cluster ever comes back, let's just say it was like a power outage and not, an actual Hurricane Sandy situation. If the log hasn't wrapped on the source yet, we'll play all that over and he'll just catch himself up. It'll be done asynchronously, so once it gets caught up, you'll see in your logs, it'll say it's in bitmap recovery mode. Once it's caught up, it's good. Or sorry, not bitmap recovery, it'll say log recovery mode. If that log has actually wrapped on the source because the destination was offline for, say, 3 weeks, we'll just say, well, this log's no longer any good for him. I'm going to take my bitmap. That's a block of data we store on our disk. And he's going to take his bitmap. We're going to compare them until they look exactly the same, as if we were doing initial sync all over again. So there's no way to ever get yourself stuck. It's not possible to get stuck in this scenario.
It's really just how long it takes to recover.
It's just a question of how long you're going to be back to being
Resynchronized.
truly protected versus getting protected. Yes.
Sounds a lot like the exchange replication in 20.
It's, yeah, this is not something anybody can patent. Everybody's been doing this for 25 years. Yeah.
So if you decide that you don't want one side anymore and you want to break that relationship, can you choose which side you want to keep?
Yeah. I mean, certainly if you want to get rid of the destination, just turn off replication. If you're using the source as your target and you want to keep the source, just by getting rid of replication and throwing away the nodes, evicting them from the cluster, you're just back to having a normal cluster now.
Okay. And then also, what if you want to expand those drives in size?
Yes. Everybody asks, can I grow and shrink? Mostly grow the volumes. We have to stop replication right now to let you do that. And then we'll turn replication back on, and you'll do a seeded sync, which would basically mostly just be 0 blocks. It should be really fast. But what we would love to do before RTM, it's my number 2 priority, is to let you do it on the fly. We're going to see if we can get it done or not. Technically, it's actually quite difficult. We think we know how to do it right. We've got some other things that are a little bit higher priority because this one has a workaround. But we definitely have heard that feedback, and I'm glad you said that because it means that you guys agree.
Very cool. Thank you. I like
Thanks.
it.
Thanks.
Any other questions?
We still have 1 minute left.
1 minute.
Okay. Is it necessary that source and destination are the same size? Or am I able to get a smaller source to a bigger destination?
They'll always be the same size. In the UI, it forces, if you go through the PowerShell and the UI, it forces you to make them to choose from 2 same size things. If you're to use the WMI, the SIM provider, when we set up replication, the destination will become the same size, whether you like it or not. Because it's, the whole volume on that destination, whatever is there is annihilated on the destination. We're setting up block replication and synchronizing a mirror. Whatever's there is gone. That's why we make you, choose available storage for your destination. So we kind of make you guarantee that you didn't have anything on there that you wanted.
What do you use to time out the destination?
I beg your pardon?
What do you use to time out the destination?
I still can't hear you, sorry.
What do you use to time out the destination?
To time out the destination?
Yeah.
From
Does
what
it go
perspective?
offline? So say the server crashes, the network goes away.
Oh, how long do we wait before we do anything? We don't wait to do anything. We just keep trying endlessly, trying to get contact back with them. And we're still letting your IOs go through. So if the destination's offline, you're doing synchronous replication. When we can no longer talk to that server, we're throwing events and alerts like crazy, but your IOs will continue on the source. We actually have a toggle. If you want, because you're a crazy person, if you want, you can set it to say, like, if my destination goes offline, I want to block all I/O. Like, that's how important I have a crazy app that we would rather not have it running than have it be unprotected. And there's a few guys like that, like in the world of financials and stock exchanges and stuff, who really do have that kind of mindset, which is why we have that feature in there, but it's not on by default.
All right,
Any last questions? Great.
All right,
Thanks very much,
you
folks. Enjoy the rest of Ignite.